All right, so we're now taking a look at our conic sections. The first conic section we're going to focus on is a parabola. So notice that I bolded the word parabola in these learning targets because that's what we're going to be focusing on these notes, okay? And once again, 8.2 is going to cover 3 of these learning targets, specifically the parabolas, okay? So first off, we're just going to start off by reviewing some parabola concepts where we're given an equation in standard form and I'm asked to analyze it, okay, by finding the vertex, the axis of symmetry, and the direction in which it opens. Well, we know that it's going to open up because our leading coefficient, our A value, 3, is positive, okay? Also, we know that's going to be vertically stretched by a factor of 3. Now, to find its axis of symmetry, we can still use our logic of negative b over 2a, where our b value is 24, so our top is negative 24. A value is 3, so we really have negative 24 divided by 6, which equals negative 4. So the equation for our axis of symmetry is x equals negative 4. Now to find the coordinate of my vertex, okay, I need to plug in my value of negative 4 into my equation because I need to find his y coordinate, okay? And so if I plug in negative 4 to my equation, I find a y coordinate of 2. So the coordinate for my vertex is at negative 4, 2. Notice that to write something in vertex form, all I need is my value for A, my value for H, and my value for K. A is going to be the same in standard form as it is in vertex form. And here is my H and my K, so I can actually also rewrite this now in my standard form here, where I have x and I have a negative 4 becoming a positive 4, and a plus 2, so voila, it is now in vertex form. Again, this was using a different approach than that of your textbook. All right, so now we're just going to take a look at graphing parabolas. So again, it'll probably just be review for you. So if we're looking at our A, notice I accidentally in mine forgot to change this to a negative. So it's really y equals negative 2x squared, which tells me I'm going to be opening down, okay, which means I have a maximum value. And I'm actually still going to be centered at 0, 0 because there's no value for B and no value for C. So something I can automatically plot is right here at 0, 0. So if I plug in the value of 1 to my equation, it's going to get me a value of negative 2. So I can plot that here, and it's also going to be the same for negative 1. If I plug in my value of 2, we're going to have negative 2 times 4, which is negative 8, which is now going to be off my paper, so I can just go down and go down, okay? All right, what about this next one where we're in vertex form? Vertex form, once again, remember, is super helpful because it literally has given me a coordinate just by looking at it. I know that the coordinate for my axis of symmetry, well, my vertex is going to be at 2, 3. And if I go in either direction, so 3 and 1 are going to have the same coordinate for y. Okay, so let's plug in 1. So plugging in 1 to my equation here, we have 2 times negative 1 squared plus 3. So we end up with 2 plus 3, which is 5. Okay, and if we plug in 0, 0 and 4 will have the same value here. So 2 times the quantity of 0 minus 2 squared plus 3. So we get 2 times negative 2 squared is 4 plus 3. So 8 plus 3 is 11. Okay. Now, these are quite large values here, and I'm also noticing once again that I just strayed from the beaten path and created a graph different than your textbook. So we're just going to ignore that and we're going to do our own thing, and that's okay. So 2, 3 is right here. And then we have a coordinate at 1, 5 and a coordinate at 3, 5. And I can connect these and we go up. So once again, just remember that is different from your textbook. Miss Rudolph made a typo, but we're going to go with it, okay? Now, it's going to be super important that you're going to recognize in this next column, you have a chart. And in this next column, you're going to be introduced to the horizontal parabola. Now, horizontal parabolas are going to be different. They're going to open to the right and to the left. And rather than being set equal to y, these equations will be set equal to x, okay? All right, let's talk about our very first horizontal parabola. I can tell that it's a horizontal parabola because my y term is being squared. So I actually want to get my equation set equal to my x term. So we have y squared now onto the other side by adding him, plus 2y plus 13. Now we can take several approaches. One of the approaches we can do is by completing the square. So I'm going to subtract 13 from both sides. So we have 4x minus 13 is equal to y squared plus 2y. Now with completing the square, we're trying to create a perfect square trinomial. So we must balance the equation and add half of my b term and then square it. So half of 2 is 1 and 1 squared is 1. Okay, so then this creates our perfect factor of y plus 1. And then over here we have 4x minus 12. Okay, now I'm going to add the 12 onto both sides. So we have 4x equals y plus 1 squared plus 12. And now I'm going to divide everything by 4, creating the equation x is equal to 1/4 of the quantity y plus 1 squared plus, you also divided 12 by 4, so plus 3. A few things to notice. We have an a value of 1/4. Notice he is positive, so I'm going to be opening to the right. Now, with vertex for a horizontal parabola, your h value is actually on the outside, so we have an h of 3, and our k value is now on the inside of our parentheses, so now he is the one we're going to flip the sign for. So we have 3, negative 1 as our vertex. Now, we're still going to make an xy table, but this time, because our parabola is horizontal, the x-coordinate is not the axis of symmetry. The y value here is the axis of symmetry, and so everything equidistant from our y value of negative 1 will have the same x-coordinate, okay? So 0 and negative 2, who are both 1 unit away from negative 1, will share the same x value. So we're going to plug in our y value of 0 to our equation. 1/4 of this quantity plus 3. So then we get an x value of, well, 0 plus 1 is 1, 1 squared is 1, 1/4 plus 3, so 3.25. Both of these have an x value of 3.25, okay? So next, let's plug something bigger in. Why don't we plug in a y value of, how about 1 and negative 3. So x is equal to 1/4. We plug 1 into our parentheses. And so 1 plus 1 is 2. 2 squared is 4. 1/4 of 4 is 1. And 1 plus 3 is 4. Okay, so now I have this little xy table here for myself. And I'm going to use that and plot the coordinates. Now I'm going to plot them like I normally do. So at 3, negative 1 is where I have my axis of symmetry as well as my vertex. And now I have a coordinate at 3.25, negative 2, as well as 3.250. I also have a value at 4, negative 3, as well as 4, positive 1. And because our a value is 1/4, it is taking a really long time for it to grow. And notice that we're opening to the right, like I had mentioned before. These are not functions because they fail the vertical line test. That's something I just want to point out. This is true for most of your conics because a parabola is still technically a conic. That's why I say most. All right, so now we're going to look at our last problem here, which is actually a real-world problem, and it features the content included in your textbook, which I've also provided for you. So some of the important information provided here. We have the ratio of f over d, where f is the distance between the focus and the vertex, is 0.6, as well as the fact that d is equal to 60, okay? So we can actually solve for f, which is going to represent the distance between the focus and the vertex, which will actually help us find the location of our vertex. So d is 60, and this is equal to 0.6. So all I need to do is multiply both sides by 60. So f is equal to, well, 0.6 times 60 is 36, okay? All right, so in the problem, it actually gave us the information that the focus is at the origin and the parabola opens to the right. Okay, so I'm going to do a little visualization here. So here's my parabola. The focus is a coordinate inside of my parabola, and this is the origin, okay? And the distance between the focus and the vertex is a distance of 36 units, okay? And so 36 units means I actually have to go backwards to the left, which is why the vertex is going to be located at negative 36, 0. Notice in horizontal parabolas that the focus and the vertex actually have the same y-coordinate. Now, another piece of information that we need to write an equation is our value for A. So something that we can use to help us write our equation is the equation for the x-coordinate of the vertex. Now, the x-coordinate of my focus. The x-coordinate of my focus is found by h plus 1 over 4a. Now, this is only true for horizontal parabolas, okay? And so the values that we know that this quantity here, the x-coordinate of my focus is 0. So this quantity of h plus 1 over 4a is equal to 0. And we also know that the fact that our h value is negative 36. So negative 36, if we subtract 1 over 4a, is equal to negative 1 over 4a. So all we really need to do here is cross multiply and divide. So we have negative 36 times 4a is equal to negative 1, and then we're just going to divide both sides by negative 36 times 4. Zoom out a little bit here. We find that a is equal to, now it's positive 1 over 144. Wow, what a tiny a value. So this actually gives us our equation. So if we have our general formatting here for a, oopsies, I just messed up the general format equation. Very common mistake. So y minus k squared plus h. So let's plug in. X is equal to a value of 1 over 144. The k value, so that's this guy here, is just 0. And my h value is a minus 36. So here is the equation for my parabola. I'm actually going to let you do part B yourself. Give it a try. You will need to adjust the scale on your graph for sure. But once again, here's a starting guideline. Start in the middle. Our middle is our axis of symmetry. And you're going to want to go up and down by the same values here, okay? So maybe you go by a distance of 36, okay? So that means negative 72 and 0 are going to have the same y-coordinate. Plug in those y-coordinates and find their x's. You can do it.